In order to simplify and complete algebraic expressions, you will need to collect like terms. Like terms. Like terms are basically all the terms in an algebraic expression that share the same variable, which would be any letter. X, Y are the most commonly used, and the same power. The coefficient does not necessarily matter because like terms do not share the same coefficients. An example of like terms would be 7x squared and 25x squared. As you can see, the coefficients do not have to be the same, as 7 and 25 are not the same, but as long as the variable x and the power of 2 remains constant. Alright, I'm going to go through some examples. Let's start off with some less difficult examples and move on from there. Alright, in this expression, what we would need to do is collect like terms. Now we would have to identify the like terms first. Alright, let's see what is the like term for 5x. It can't be 8 because it does not share the same variable, and it has to be negative 2x because it shares the same variable and the same power of 1. It doesn't show because it's not correct communication. Alright, 5x minus 2x would give you 3x. And the other like terms are the constant terms, which have no variables. Positive 8 plus positive 5 is going to give you 13. So from this expression, we can simplify it and make it a lot shorter into this expression right here. Alright, let's move on to the second example. The second example is 5xy plus 6y squared. Sorry, 6x squared actually, plus 8xy minus 9x squared. Alright, first off, let's try and identify the like terms. Alright, the like term for 5xy would be 8xy, as it is the only term in the expression that has a y variable. So 5xy plus 8xy is going to give you 13xy. And the other set of like terms would be 6x squared and negative 9x squared, as they share the same variable and the same power. So 6 minus 9 is going to give you minus 3x squared. Now let's up the level and move on to something a little more difficult. When subtracting or adding trinomials, which are a set of polynomials that have three terms in it, when subtracting them, what you would have to do first, the first step would be to distribute the negative sign. So distribute the negative sign to all three terms on the second trinomial, just like that. Alright, so for the first step, we would maintain the first trinomial the same, so we would make no changes to the first trinomial. As you can see, it's the same, 3x squared plus 5x minus 6. But for the second trinomial, we would have to multiply all of the terms by negative 1. So negative 1 times 4x squared would be negative 4x squared. We're essentially changing all the signs of all the terms. So positive 7x turns into minus 7x, and minus 3 turns into positive 3. Now we could identify the like terms. So 3x squared is a like term as 4x squared. Positive 5x is a like term for negative 7x, and negative 6 is a like term for positive 3. Alright, now let's simplify the expression. 3x squared minus 4x squared is going to give you minus x squared, as it is minus 1. Positive 5x minus 7x is going to give you negative 2x. And negative 6 plus 3 is going to give you minus 3. Alright, let's move on to the second example. The second example is 7 times 3x squared minus 8x plus 2. Alright, so what we need to do here is distribute, just like what we did right here, distribute the 7 to all of these terms in the trinomial. So 7 times 3 would give you 21x squared. 7 times minus 8 will give you minus 56. And we have to bring the x because we're multiplying it by x also. And 7 times 2 would just give you 14. Alright, now let's up the level one more time and see what we could do with multiplication in a algebraic expression. In an expression like this, what we would do first is, as you can see, I'll put it in different colors. There is a coefficient on both terms. There is a variable or 2 on both terms, and there is exponents. Alright, so the first step you would need to do is multiply the terms, which are the coefficients, which are in red. So 7 times 8 would give you 56, right? And now let's start off with x. Okay? So x squared times x cubed would give you, anytime you multiply terms which have exponents, you add them. So 2 plus 3 gives you 5. So x squared plus x cubed will give you x to the power of 5. So let's add that to our equation. So x to the power of 5. And now let's move on to the y term. Y to the power of 3 times y to the power of 4 is simply 3 plus 4, which gives you 7. So that would give you y to the power of 7. Alright, so from multiplying these two terms, you could get 56x to the power of 5 and y to the power of 7. Now let's move on to our last question. So 5x minus 4 squared in brackets is a binomial product, but also it simply means 5x minus 4 times 5x minus 4, as anything to the power of 2 is itself multiplied twice. So 2 to the power of 2 is 4 because it is 2 times 2. So you're just repeating the multiplication twice. So now that we have the 5x minus 4 times 5x minus 4, we could distribute on both sides. So this is basically a foiling question. So foiling, in another video I posted, it means first, outer, inner, last. This is multiplying of the binomials. So you could go 5x. First, what we do is 5x times 5x will give you 25x squared. Remember, anytime you multiply x by x, it becomes x squared. Now you do 5x times minus 4, which gives you minus 20x. And now you do minus 4x minus 5x. Sorry, minus 4 times 5x will give you negative 20x again, and minus 4 times minus 4 will give you positive 16. Alright, we're not done just yet. What we need to do first is collect the like terms, which is negative 20x and negative 20x. So that would give you 25x squared. Minus 20 minus 20 will give you minus 40x plus 16. Alright, so this is a trinomial in its binomial form. So a quick recap about what we went through is collecting like terms in algebraic expressions means to add or subtract terms that have the same variable and the same exponent, such as x squared and 2x squared. They have the same variable and they have the same exponent. And algebraic expressions can be as simple as 5x minus 4 minus 8x plus 3, or it could be as difficult as questions like these and even more difficult. Alright, thanks for watching.